Took a look at everybody's projects last night and also Sunday night. And it seems like there was a lot of difficulty getting the EMR step to work.
To be honest, in a single day, after running on mode for like 2 minutes or 3 minutes, my VMI cluster was getting terminated with error 15 times. 15 times.
So this is the thing is it sounds like a simple transition to make. You know, you take a notebook, you turn it into a Python file, and then you start running it on EMR. That is not always the case. A lot of the time, the transition can be more complicated. And it involves more work than you think it will. Now, what I think happened, and you can correct me if I'm wrong, is that many people were blindsided by that. By like, okay, you had Spark code working, and that was the hard part. So you just have to go and get it working on EMR. And I think it took a lot longer than most people were predicting that it would take. Yeah.
For me, my code was running on Friday, and when I checked on Sunday, I'm getting this error. Same code, nothing different.
Yes.
It's just a difference between a number of hours. I checked my code on Friday, I got output perfectly, everything is perfect. When I tried to run on Sunday, I was just getting terminated with error all of that.
And this was in the EMR step, or this was in.
EMR.
So you were able to create the EMR step once, and it worked the first time.
Yeah.
And then it failed again.
Before submitting, I thought of checking it once so that like before submitting. And when I tried it on Sunday, I was getting error continuously.
Okay. We'll look at it after class. So I think partially what happened is also the fact that I made using these in-person or these interactive clusters maybe too easy, right? Because I gave you, a few commands that you could run to start up your cluster and connect to it. And since I'm an engineer and I just want to set something up, I don't want to necessarily have to understand everything that's happening. I just want to set up my dev environment. And so that's what I did for you guys. But after looking at these submissions, I realized that may have been doing you a disservice. Because using the EMR cluster interactively didn't require you to understand how the connection worked. And that may have hurt you when you tried to translate it to EMR. Now, I did provide an example of how to create a scripted EMR step. And some of you did notice that there were slight differences between the scripted version of the code and the interactive version of the code, and you put that in your submissions, which is good. So there were a few people that I was able to run the EMR step for, which is nice. However, since it seems most people had a hard time connecting to the EMR cluster and setting up the step, we're going to kind of start from square one, at least where the infrastructure is concerned. Because from the Spark perspective, when I read everyone's code, I was happy with it. I think that all of you have successfully learned how to program most things that you would want to do in Spark. So I feel like we're done, and I don't really need to cover that subject in further detail. So I think all of you have been very successful there. Are there questions so far? Okay. So what we're going to do now is we're going to go over the infrastructure that we use, and I want to make sure that you understand every part of what is happening here. And so based on your submissions, you've already pretty much proven to me that you understand Spark, which is why I've decided to make a little bit of adjustments and put more emphasis on the exam on the infrastructure, because that's where I saw the most deficiencies. And so we need to address that. So we're going to talk in detail about the infrastructure. Questions on how we're going to proceed so far? Okay, let's get started. So we'll start with a basic definition. When you create an EMR cluster, what is a cluster? Bianca, what's an EMR cluster?
It's just like it's a creative cluster to connect with your Spark machine with your like Spark connect Spark with your machine.
Yeah, but what's the cluster? What is the cluster?
That's
So,
it's a remote configuration mechanism. Like
someone want to help? What's an EMR cluster? Yeah.
It's a network of AWS like compute nodes that are connected over Hadoop to do large data processing.
Yeah. It's a group of AWS EC2 instances that are communicating with each other to process large amounts of data. So when you have this group of EC2 instances, like where do they live? How do you actually address them, right? Because an EC2 instance is a virtual machine that lives running in AWS somewhere. It's a physical thing that's running somewhere in the world, right? So how do we find that? This SSH command that I gave you all will, you can't see this. This SSH command that I gave you all will take the DNS address, which is how you can reach this specific EC2 instance that you started from the internet. That's what this command is for. So you can take a shell or a terminal on your local machine and SSHing into that EC2 instance basically means you can connect to the instance directly and start a terminal session. And that way you can do what you want there, which is why after we SSH into it, we can do things like start the Spark Connect server and tail the log file for the Spark Connect server, and we can control yarn through application lists and kills, things like that. So this command allows you to directly connect to this virtual machine that we started somewhere in AWS. Does this make sense? Now, every machine in AWS and any machine connected to the internet will have an IP address associated with it. What's an IP address? Yeah, it's an identifier. It's not just an identifier for a machine on the internet, though. It also has information on how to get to that machine from anywhere else on the internet, which is why when you visit a website, they're usually pretty good at roughly guessing your location. That's because they use your IP address. Your IP address is correlated with your location. It tells the internet where in the world that computer is. That's how the routing works. And you'll notice that for each of these, for the primary instance and the single core instance that we have in this cluster, we have a public IP address and a private IP address. The public IP address is globally accessible. So we can directly connect to just the IP address. We don't have to use the domain name given to us by the AWS console. Okay. So we have this SSH command that we can copy and paste into here that it'll automatically give us. Now, this is a DNS name. This is a globally you can't see this. Damn it. This is a globally accessible DNS name that you can connect to from anywhere in the world because Amazon automatically creates one when you start up an EC2 or an EMR masternode. This is equivalent to just connecting to the IP address directly. We can do that. So we wanted the public IP address. We'll get to that. So we can connect it using just the public IP address, and that allows us to connect to this specific machine that we started just a few minutes ago. So right now, this terminal is running somewhere in AWS's network. We are connecting through our local machine, and we're forwarding all of the key presses to execute on the remote machine. That's what's going on here. Does it make sense? Yeah. You could. We could arbitrarily change this IP address to be anything else, and it may or may not respond with that. And whether or not it responds depends on a few things. It depends on, well, first of all, you have to contact an IP address on a specific port, and we'll talk about that in a second. So it depends on whether that port is open. So if there's a process on the machine you're trying to connect to that has opened to the port, that matters. If the port isn't open, you won't be able to connect on it. If it's even accepting connections through the firewall on that port, because that's something totally different. Because sometimes the network, based on the port number, will stop the traffic coming through before it even gets to the machine. So it depends on the firewall as well. That has to do with the security groups that you set up, or that you had to at least check when you were starting your initial EMR clusters. Does anyone remember that? Yeah. So I instructed you to make sure that the security group contained permission for ingress on port 22. Does anyone remember that? Yeah. So if we look at the interactive EMR part of it, so port 22 is interesting because because port 22 is specifically configured to be for SSH. There are certain port numbers, as a standard across the industry that are delegated to certain types of applications. So SSH is actually a server that runs on the primary master node, the master node in EMR. SSH is SSHD, SSH daemon is a server, and its job is to open port 22 and accept SSH connections. So when we execute this command to SSH into our primary machine, what happens is we take the IP address and we take the port number. We take that combination and we send a request over the internet to talk to Amazon's EC2 instance for the primary node. The SSH daemon server process running on the primary node will pick up this request and it will look at your public key. And it'll check if your key matches the thing that's allowed, matches whoever's allowed to connect to the server. If I put in some other key file, then it's not going to allow you to connect, right? I think some of you have experienced this. If you forget to put in the key file name, then it will refuse the connection. Yeah. It's not specifically a Linux thing. You can use it on Mac too. No, they're cousins. They have a common ancestor. Um, they're not exactly the same, but they're similar enough that if you read guidelines for setting up something on Linux, you only have to make smallish tweaks for Mac, usually. They have different package management systems and stuff like that based on the distribution, but they're usually similar enough where if I need to do something in Linux, it's almost exactly the same on Mac. So it's like this is a Windows machine, and I face issues all the time with switching between my work machine, which is Mac OS, and my personal machine, which is Windows. I have problems with that all the time. It's so annoying. If I have to switch between Mac and Linux, seamless. It's easy.
So most servers though are Linux, so that's why when you're like, you've been SSHing servers, it's because they're running Linux, right?
Well, it's because they're running SSH daemon.
And
Well, so just remember that an IP address and a port number, they don't know about the operating system of the machine they belong to, right? So you can connect to a Windows machine running SSH on port 22 because SSH is just a protocol. There's nothing strictly operating system, there's nothing strictly operating system specific about it.
there's a server software, there's a software that has been running the server.
Yes.
Okay.
But it's an interface. So it's an externally facing protocol. It has defined interactions that make it able to connect to other types of machines. So like I have a MacBook, an M1 MacBook Pro for my work machine. That is Mac OS. That is a completely different operating system than, Amazon Linux 2023. But I can SSH from something like Mac OS into something running Linux. And because even though they run different operating systems, they use the same protocol for communication. It's kind of like speaking the same language, right? They have the same standardized rules on how the communication is supposed to work. We're getting into distributed systems territory right now. This is 555 material. What do you mean they don't teach it now?
Took it last semester.
Yeah, they only teach it every fourth semester. So spring even years, yeah. It's not offered very often. We should make it offered more often though. It's an essential class to almost anyone who wants to do engineering, unless you're doing like deep embedded systems work. You're going to interact with distributed systems at some point in your time as a developer. So we do, and whenever the class is offered, it fills up to like 50 people. I don't know how the teacher manages it. We need to teach it every year. We're going to start teaching 535 every year too, pretty soon. This one.
Oh, of course it is.
So we have, our list of registered port numbers, list of TCP and UDP port number. And a lot of these are going to be pretty familiar, right? You have, SSH, which is on port 22. You have Telnet. Has everyone heard of Telnet? Everyone use Telnet? Yeah, it's kind of like SSH, but there is no encryption or authentication whatsoever. And I have used and email servers. There is an email protocol, the simple mail transfer protocol. And email servers are defined to accept connections on port 25. So if you want to connect to Google Gmail email servers, you do it in port 25. Because there's a standardized email protocol that the internet uses. And we have this one too, the time protocol. You know, how do you think all the machines in the world keep track of what the time is? We have to be constantly, sharing what the current time is, because it turns out that the clock on your machine is not actually all that accurate, and it will get skewed if you let it run on its own. So there is an internet protocol to continuously read from like a few atomic clocks all over the world and then share what the time is all over the internet. This is a thing.
So where's the master clock?
It's in a few places. There's like um list of atomic clocks. There's a few of them. There's not very many. It's like this. Yeah. And what's interesting about atomic clocks is that the length of a second is calculated by the number of oscillations for a specific electron in a cesium atom. I'm not kidding. It's this exact number of oscillations for this specific electron in a cesium atom. It's wild that like this is how they define time. Which is why they have the type CS, that's cesium. That just reminded me of that fact. I thought it was interesting. So we have the time protocol, right? And then, oh yeah, DNS. Port 23 is DNS. This is what enables like the internet to internet. The internet can't internet without DNS. DNS is the service that takes the name of your website and translates it into an IP address. Imagine how much of a pain it would be every time you wanted to do a Google search, you had to manually find out what Google's IP address was. What a pain. So the DNS system specifically exists to be a real-time mapping between an abstract domain name like google.com and an IP address that gives you the address of a machine that you can communicate with. It's easy to forget that literally every time you submit any web request to talk to anything, you are talking to something real, tangible, physical that exists somewhere. There's no such thing as cyberspace. It's just a computer somewhere else. You just don't know where it is. When I was like 6 years old, I wonder when I download a file, where does it come from? Because it it felt like when I was a kid, it came from like thin air. I was like, no, it's just the illegal file I'm downloading is just hosted probably in Ukraine somewhere. Who knows? I used to download Game Boy Advance games illegally when I was in elementary school, and that was a good time. Anyway.
I was like seeing where all of the like people I'm downloading this torrent from are.
It's all over the place.
Yeah, but it's usually like 50% Russia. So
And yeah, here we go. The classic HTTP. HTTP has a defined port number. You've heard of all of these protocols and Tor. Tor. We don't need to talk about Tor here. That's a whole other thing. HTTP has a defined port number. So if your machine is running an HTTP server, it is expected to receive connections on this port. And it's the same thing with HTTPS, wherever that is. I think it's 443. Yep. Okay. Network time protocol. This is the time synchronization that I was telling you about. And there are all sorts of familiar things in here. There we go. Port 443 is HTTPS. If you're running an HTTPS server, you are expected to receive connections on this port. So just like everything else on this list, SSH is a very widely standardized protocol that you use to connect to a machine and execute commands on it remotely. That's what it's for. And so when you want to receive or when you want to connect to a machine over SSH, you need one, the machine that you're connecting to be running the SSH daemon, because SSH daemon is a server that accepts SSH connections. You can't just SSH into any server you want. You can't SSH in any machine you want. The machine has to be running the SSH daemon server.
Default, like, most of the time, like, if you buy a laptop, by default, it is.
It might not be. So when you start an AWS instance, that's by default running. So AWS probably has some configuration somewhere that automatically starts up the SSH daemon when you start up the machine. And I would have to refresh myself for exactly how this works, but there is a registry of server daemons for your machine that are supposed to start up whenever your machine starts up. And SSH is one of them. Questions so far? Yeah. It does. We can SSH into a core node if we want to. It's possible to do. So I forget the syntax on how to do this every time. You want to try it? Or not CD, exit, silly me. Okay, so this is special. In order to SSH into, or in order to SSH into a core node, the core node also expects us to give it this key file. We don't have access to the key file on the master node. The key file is local. We got to copy it over. So we're going to use this command called SCP, which stands for secure copy. So secure copy uses the SSH protocol. Oh boy. I forget the syntax for this. Nope. Okay, that works. Linux VM. Okay, so what this means is, I'm not even sure I got the syntax right. We're going to find out in a second. So we're going to take this local file, we're going to connect to this machine, and we're going to put it in this path, which is just the home directory, on the target machine. Let's see how this works. What did I do wrong? Help. Forget SCP. Try to SCP via SSH. There you go. Oh, I see. There's no other. I see what it is. Okay. It's just one slight change. Okay. So this is the file we want to copy over. And the second argument is the destination. So it's two arguments. Okay. So we copy that over. So now when we SSH into it, we should be able to see our PEM file. Okay. So we just move this over from local. So now we need to take the core node, and I'm not going to actually connect to the public IP address of the core node. I'm going to connect to the private IP address. So we'll connect to the private IP address. SSH, Hadoop, at, there's no space there. All right, what's wrong with this picture? We're missing something. What are we missing? Yeah, we're not specifying the key file, so this should reject us. Okay. Access denied. Now let's see if it lets us do this. Ah, there we go. So now you can see the IP address we're at is different. So we actually are in the core node now. And so now, if we do a list, we don't see the PEM file because we're not actually in the master node anymore. We're in one of the core nodes. So then if we exit, so now we have double SSH'd. So we're SSHing from the master node into the core nodes. We're not SSHing directly from our machine into the core node. We SSH into the master node, and then from the master node, we SSH'd into the core node. So we were double SSH'd.
When you did that.
It just specifies the PEM file. That's all.
Oh,
It's
if you don't have that, it doesn't know that you're about to say it.
yeah, it's just an option to specify a PEM file. Okay, questions so far about how SSH works? Okay. Just so we're clear, what's a port number? Yeah, what is a port number? Not what's the port number, what's a port number? Like the idea.
Specifies like it's used to communicate like where you're going to talk to an IP address.
Yes. So a process, like a Unix process on your machine, will start a server and it will start listening for connections on a specific port. Because, just communicating with an IP address isn't enough, right? You need to be able to specify what you want to do with that IP address. Do you want to SSH into that IP address? Do you want to send an email to this IP address? Do you want to, send a web request, like an HTTP request to this IP address? You need to know which one of those things you want to do when you talk to this IP address. And the port number that you specify tells like the network interface in the operating system that you're communicating with which process to send your network connection to. So, for example, you have a client and this client is connecting to a server and you have it listening on port 22, which is the SSH daemon. And then you have it listening on port 80, which is the HTTP daemon. And then I don't even know what the HTTP daemon is called. It might just be called HTTP. And then let's say we have port 25 because we want to send an email. And let's kind of look this up. 2, 5. Okay, there, that's better. Simple mail transfer protocol daemon, or whatever it's called in real life. Let's pretend that's what it's called. So depending on what port number I want to specify is if I connect to this IP address and you specify the port with a colon, you'll notice if you ever connected to the Spark UI, you specify a port number with the colon, right? You have the domain name, which is just localhost, and you have a colon, and then you have a number. That's a port number. That port number tells you which process your code wants to talk to, or your connection wants to talk to. So let's say we want to send an email. So we connect to port 25. The operating system that belongs to this IP address receives this request and says, hey, this request is going to port 25. So we'll send it to this process.
Let's specify what port. Like if I go do a Google search. So it goes to a DNS server. That DNS server maps to an IP address. Is it mapping to an IP address on the port? How does it know what port to ping when it gets set up?
That's part of the standard protocol. So your browser kind of hides that from you. unless you specify it.
So it's my browser that's adding that?
Yeah, it could be your browser that's adding it, or it could be the JavaScript in your browser that's adding it, or whichever. So somebody is specifying a specific port. Usually port numbers are abstracted away from normal users, and your browser will kind of take care. We'll figure out which port it's supposed to communicate with, because sometimes it's port 80 when it's just HTTP, and sometimes it's port 443 when it's HTTPS. So that depends. And normally when you make a network connection, you specify a port, right? So you can specify a port number in your local URL bar on your browser. That's what's happening with the Jupyter Notebook right now, right? The Jupyter Notebook is a server that runs on your machine, and this server is accepting connections on port 8888. And it follows the exact same logic as everything else. Is the code that's running in your browser that wants to connect to this Jupyter Notebook server starts sending requests and communicating with whatever lives on port 8888. It's the exact same process as everything else that's going on here. Questions so far? Yeah.
What's the difference between SSHing like twice, like we just did, and four?
Okay, I'm glad you asked that. We will get to that in a few minutes. Okay. So you'll also notice that in our example code, this is ways down. Okay. When you get to our example code, when we connect to Spark, we specify this address. So this tells us the protocol. So it's a Spark Connect protocol. So you'll also notice that, in the URL bar, you have HTTPS, and that specifies the protocol. And a lot of the time, the protocol has a standard port. So like how SSH is always port 22, HTTPS is port 443. This is probably how your browser knows it's port 443, is it reads the HTTPS part of the protocol, and then a little pending port and all that. So what this is telling the Spark session builder is that you are going to connect using the Spark Connect protocol. So you expect this address and port number combination to be hosting a server that uses or serves the Spark Connect protocol, that implements the Spark Connect protocol. Who can tell me what Spark Connect is? So just like everything else we discussed here, Spark Connect is a server that just runs. And it runs accepting connections from a specific port number. In this case, the port number is 1502. Is 15002. That is the standard port number for a Spark Connect server. Now, Spark isn't a popular enough, it's not a ubiquitous enough piece of software to have officially standardized this port number, I think. But this is what they use. Is that they'll look for something that nobody else is using, and then they'll pick one. I don't want this to clash with anyone else, so we're just going to pick this port up. So that's what this is telling it. This is telling your code to reach out to localhost, which is your machine, and reach out to your machine, which is supposedly running the Spark Connect server. But we know your machine doesn't run the Spark Connect server. The master node does. So why are we connecting to the Spark Connect server on localhost instead of the master node? It's not just the SSH part. Because we'll see right here, I'm SSH in the EMR right now, right? If I try, let's not go there right now. That's for later. If I try to connect, this is going to run. There we go. If I try to connect to the Spark Connect server on my local machine, it's not going to work. So why is it not going to work? We didn't start the Spark Connect server on EMR. So let's go and do that. This is how you start the Spark Connect server. So we have a script that lives somewhere on the EMR master node, which starts the Spark Connect server. And this is just specifying dependencies for starting the Spark Connect server. So this command starts a server that accepts connections, which allows you to actually use Spark remotely. Questions? Yeah.
How did that SH
It's automatically included.
by whom?
Amazon.
So Amazon had a whole list of things that they automatically included, and that's one of them.
Yes.
Okay. Okay, so I still don't understand why I'm not saying connect to the Spark server on my EMR.
We'll get there. We're getting there. Okay. So let's start the Spark Connect server. Oh joy, it worked. Okay, now let's do the last part, which is just tail end of this file. And see what's happening. It'll take a minute. You started yet, sir? Oh, there we go. Yes. Almost. Sometimes it takes. I thought I saw something up there. Where did it go? It's got to be somewhere over here. Like somewhere in this file, it will say that it is serving Spark Connect on port 15002. Somewhere in here. Let me know if you see it. You saw it down at the bottom? There it is. Okay, that's what I was looking for. I always lose track of it. Okay, this is what we were looking for. Spark server started at whatever, localhost 15002. Now, this clearly is not working because from experience, it never takes this long to connect to Spark Connect if it works. So kill it. Yep, and we'll try it again. Mm-hmm. All right, this ain't working. I'd be worried if it was. That means we're doing something wrong. So this still isn't working. What are we doing wrong? There's a missing connection here, right? Because this is serving the Spark Connect server. It's accepting connections with the Spark Connect server on port 15002. And that's the master node for the EMR cluster. But we're contacting localhost, which is our machine. So that doesn't work because Spark Connect server isn't running on our machine. It's running on the master node. So how do we communicate with it? That's the port forwarding. So the essential part here is that when you SSH into the master node using this command, it has a secondary effect. In addition to giving you access to a terminal, it also forwards the ports so that when your machine receives a connection request on 15002, it will forward everything from your port 5002 to the master node's port 5002. Does that make sense? So in this situation, we have Jupiter, which is connecting to localhost 15002. So localhost doesn't know what 15002 is because we're not running the Spark Connect server. What's happening now is we set up port forwarding on SSH. And so what SSH does is it says, okay, we're going to take this port and we're going to map it to the same port on to the support 5002 on the EMR master node. Does that make sense? Okay. So now every connection that goes through here, SSH will forward to the EMR master node. And the EMR master node will then send it to SparkNet. Does this make sense to everybody?
But this keeps working even if I don't remain SSH into the cluster, doesn't it?
No, it does not. You have to remain SSH'd into the cluster for this to continue working.
So if I had exited out of that, the whole thing would be great. I think I never realized because I was reading the log file phone.
Yes.
Even though I never looked at it, so I thought, what comes out of this? And then I never did, but if I had, it would have not worked.
Yes.
Okay.
So that's why is this SSH is pulling double duty, right? It allows us to look at a live tail from the Spark Connect logs, and it also keeps the SSH port forwards open so that we can connect to the EMR Spark Connect server from a local port. And this is really convenient because it means as long as, the firewall, as long as Amazon's firewall allows port 22 traffic, then we can open whatever port we want.
There's time limits on that?
No. As long as the SSH connection remains open.
For SSH. So I could indefinitely say SSH into something?
Yeah, I mean, there are settings for that, right? Like if there's no activity on the connection, it'll die, but you can turn that off. Questions so far? Does this make sense to everybody?
Why did you have us do it this way?
Huh?
Why did you have us do it this way?
Instead of what way?
Well, I don't know another way, but it seems like Okay, well, that's cool, but certainly there seems like a more. Well, maybe not, maybe there's not a straightforward client server way of doing it, but if Spark Connect is a server that runs on EMR, seems like. It would be designed so that. People running Jupyter notebooks who are trying to start Spark sessions could connect to it. Is this the way they connect to it? The way?
So we use Livy at Count, which is another server that lives on the Spark or the EMR masternode, which can also accept connections and communicate with Spark on your behalf. Now repeat after me. Livy is the worst. Never use it. And the reason we don't use it is because it's a poorly maintained piece of software that's been around for like 15 years and still hasn't had a stable release. Thank you.
So this is a standard way that people use the Spark Connect server.
So you might ask yourself, okay, why don't we just open public traffic to the Spark Connect server on 1500 to connect to it directly? So why don't we just
Like where it says remote, we put the IP.
we put the IP address in? Why not just do that? It's because SSH has built-in authentication. We can just take advantage of that. Spark Connect doesn't really have that. And so with SSH, so we keep the EMR master node, we keep the public port closed on 15002. SSH has built-in authentication methods that we can take advantage of. And SSH is a very well-tested piece of software. It still occasionally has, security bugs like Heartbleed, but when you need to authenticate via SSH, or when you need to SSH into a cluster or use a cluster's resources, you don't want anybody on the internet being able to use your cluster. So doing it through SSH port forwarding, in order to forward those ports, you need permission to SSH into the cluster.
Which is why you have a private.
Yeah. And so I am using SSH port forwarding as a security measure for authentication.
Okay, so the public IPs you never need a key for that. You never need.
You never need a key to submit a request or to initiate communication with an IP address. You never need a key for that. The server on the other end could see your key, process the request, and then refuse to respond or communicate with you, shun you. Just rude, not even respond. But that's what it will do, right? You'll notice, I think I showed this to you in a demonstration. If we tried to SSH into the EMR master node and we were not allowing port 22 traffic in the security groups, then it just hung and then timed out after a while. What was happening is our machine is sending SSH requests to this IP address, this server, but Amazon Security Group isn't even letting the request in. So we keep sending them and we don't get a response and we're like, okay, we give up. That's what the timed out means. So I do this because in real life, if you were trying to connect to a cluster, you would never expose the Spark Connect port publicly. You would do it through some authenticatable method like SSH or whatever. Questions?
What are the other IPs?
So there's one other IP address. Okay. The other ports are these three other ports are for the Hadoop UI and the Spark UI. So right now we're not forwarding anything. Yeah, we failed to connect. Neat. Okay. So let's go back. So the Spark Connect server is still running even if we exit out of SSH. Okay. So now let's add that little port forward over here. Okay. So now we can SSH back into this cluster, and hopefully when we try it a third time, it will actually work. Let's go. Let's forward that port. Ah, there we go. It finished. So now we can load in some tables, and let's see if that works. It should only take a few seconds. Hey, we got it. So if we don't have the port forwarding, remember this command is exactly the same, except now it has the port forwarding. So if we don't have the port forwarding, this doesn't work because our machine is not accepting connection on port 15002. This creates the port on our local machine. That's what this does. Is this clear to everybody now? How this works?
How does that know to send it to? Like, what is it? How do you explain that? Like, I see the local host and that port.
Okay.
How does that local host and that port know to send it to the server? Is that first 15002 telling us the port of the previous ID?
This is the local port. This is the remote kind of host name, and this is the remote port. So
SSH.
So this is the local port that we're forwarding from. So let's do an experiment. Let's change that, right? Hello? Are you gonna help? Okay, let's kill this while we're waiting. Okay. All right, there we go. That took a fat second. Okay. All right. So let's change this to port 15003. Once we do that, we restart this. Okay. This is not going to work anymore, right? Because we created a Spark Connect port forward from local port 15003 to the EMR master nodes port of 15002. So because now forwarding to a different port, this code doesn't work anymore. How do we get this code to work? On.
So I'm going to put the local host to like 03.
So let's kill this again. Let's try it again. All right, looks like we got it. And this should return much quicker since it's already cached. What? Oh, yeah, we need to, because we restarted the thing. All right, yeah, there we go. It's already cached. Great. So that's what this means. This is the local port that we're forwarding from, is the first number. This is the kind of remote host that we're forwarding to, and this is the remote port that we're forwarding to. Got it?
forwarding to, which direction are we going? Are we forwarding to the EMR cluster, or are you talking about the Spark Connect forwarding to us?
We're forwarding to the EMR cluster.
Okay. Why is the remote host called local host?
So that is more complicated because there are multiple IP addresses and hosts that a port can be serviced on. And unless you are targeting that specific IP address, you can't access that port, which is interesting because I didn't find this out. I found this out the hard way. I was trying to, write the instruction set for you guys to connect to an EMR cluster, and this works just fine. But you'll notice that the port forwarding for 20888 and 8088 are different. This one forwards through localhost. These two forward through localhost, and these two forward through the primary's private IP address, the EMR master node's private IP address. If you replace this private IP address with localhost, this port forwarding will not work.
What makes sense why it would have to be primary private IP? What doesn't make sense to me is how it works with this local host. Because what you're talking about is
It's localhost with respect to the EMR master node. So it's the EMR master node's localhost, not your localhost. So this localhost is not your localhost. It's the EMR master node's localhost. Does this make sense to everybody? Okay. So the weird thing is that ports are only hosted on certain IP addresses. You can only access the ports from certain IP addresses. And I don't remember exactly how I figured this out. Like, I'm just gonna check PT because that's how I figured this out. List port numbers by IP address. Okay. Is it netstat? Okay, let's try this. So let's see if this gets us what we want. Okay, I think that does get us what we want. So you'll notice, okay, localhost is 127.0.0.1. We know that, right? So localhost is just an alias for this IP address. This IP address is a loopback IP address that refers to the same machine. That's what this IP address means. On every machine, that's what the IP address means. It just means the same machine. So on machine A, this IP address refers to machine A. On machine B, the same IP address refers to machine B. And on machine C, the same IP address, 127.0.0.1, refers to what machine? Machine C. So 127.0.0.1 always refers to the machine that it's hosted on. It refers to the local machine. So localhost and this IP address mean the same thing. Localhost just an alias. And we can actually kind of see the mapping. Want me to show you the mapping? Etc. Where is it? Hosts? Is it host.conf? It's host.conf. Multi-on, that's not helpful. Is it hosts? I think it's hosts. Okay, there we go. So what this basically defines, specific aliases for specific IP addresses. So this is an IP address, and these are all the aliases for that IP address. Make sense to everybody? Okay. I just thought that was a cool tidbit. Anyway, we click to netstat, and we see that where is Where's the Spark Connect server? It's got to be on here somewhere. Is it not here? Why? You see that one? Am I just blind? Does anyone else see the Spark Connect server? Where are you? Oh, you see this? That's SSH daemon. Okay, well, anyway. So you'll notice that these two IP addresses, 20888 and 8088, are both listed. Where is 8088? Here. This is the private IP address for the master node. So if you look at the master node, you'll notice this private IP address, 172.31.40.88. 172.31.40.88. So this is the same private IP address that is listed on the AWS console. And so it's serving the port number, this port number, 80888, with this local address. It's not from localhost. It's from a different local address. Which means that if we were to execute this port forwarding and then try to access whatever is on this port using localhost as the port forward, it will not work. We have to use the private IP address. I can show you this. So take these three and copy them. Is it? You better not take long this time. Don't do it. Don't. When I was 5 years old, my computer teacher told me that pressing enter makes it faster. And I know now that she meant like when you do a Google search or something, pressing enter is faster than clicking the magnifying glass button. But when I was 5 years old, I thought it meant it'll tell the computer to go faster if I press enter. So I would do that a bunch of times when I got impatient. Sometime today would be great.
Can I ask a question while we're waiting?
Yeah.
In that other list we had, when it was 0.0.0.0, is that also localhost? Is it the parts like can you use localhost for those?
Yeah, I forget what that is. Is that another local address? I forget. Oh, okay. So it's used for all of them? Yeah, it's used for all of them. So you could do it. So you could do either localhost or the private IP address or the public IP address or whatever. That's what it means. Come on. Maybe. Let's try that. There, that worked. Thank you. Okay. Now, before we go, I just want to show you this one last thing. Okay. And we're not doing port forwarding for Spark Connect, but I don't care right now. We're just looking at the. Okay. Okay. Let's do localhost over here and localhost over here. Okay. So now You try and access. This. Oh dear, the connection was reset. What shall we do? Well, we already know what the problem is, so let's just do it. Yeah. I'm aware. Thank you. Okay.
Look at that. Can you use the private IP for all of them, even this version of your local host, remember?
Probably not, because it was bound to the loopback address. We can always try. My guess would be no, but
Private addresses on- Because it never actually connects to the actual. If it's not interchangeable with the actual IP.
no, what?
If you can't use the actual IP in place of the loopback. Or the local host like that, you can 127.0.0.1.
Yes, you can. We can put 127.0.0.1 in place of localhost right here, and it works.
Actual local IP in all of this. Like 172.3.1.4.40.88, when we replace all this local host with that.
Yeah. Let me demonstrate. Oh, okay, there we go. It worked. This is why we need that. So if you look at netstat will tell you that the port number for the Hadoop UI is served with the private IP address of the EMR master node. This is why we have to forward the port using the private IP address instead of the loopback address. Does this make sense to everybody? Great. I'll see you on Thursday. And we will continue our infrastructure learnings / talking about project 1 / exam review.
Okay, so instead of this local host, then I actually use 172.31.40.88.
We'll try it. That's an interesting question. Because if we look at netstat, doesn't seem like it's listed on here. That's interesting. Okay, let's. Oh, oops. Okay, yeah, huh? I am looking for what was it? 127.0.0.1:4040 or something like that. So my guess here, actually, let's do this again and test that looking at the Spark application works. Okay, there we go. That worked. Okay. So now you're asking if we replace this local host with the public IP, will that work? Okay, let's try that out. Exit. Okay. Okay, it did work. So it looks like using the public IP works too. All right. If there are no more questions, go fight win. Not that you have anything to work on right now. What?
Sure, I use the orange and that's coming out. I would love
Or at some point, for spring classes.
Yarn is a resource manager. So when you ask for executors, Yarn will allocate memory and processors for Spark to use.
Okay. Is it cleaned up too? Is your garbage collector as well?
Depends on what you mean by garbage collector. It's not the JVM memory manager. It's higher level.
The cheaper question. My steps run successfully. I was nervous. Yes. Yes. Yeah, I have a question regarding midterm. What kind of question, like it's not actually question, but type of question we can expect, like pattern or something like an MCQ or
Clear response.
few response.
Words.
Sorry?
Words.
Words, short answer.
Mhm.
Short answer, you mean?
Maybe not necessarily short answer, but yes.
Um,
Um,
Is it going to be online or offline or what kind of institute?
no, I haven't written it yet. We will go through that in the exam review. I will only do the exam review after I write the exam. So then I can tell you what to prepare for.
And which date is scheduled for this?
Huh?
Which date is scheduled for this? 7. 7.
Yes, I am planning to have the exam on November 7th.
Yes.
Probably.
Probably, oh my God.
I will tell you when the exam is. I have to write the exam.
So basically.
No, I'm not gonna have you walk in one day and be like, hey, guess what? You have an exam today. Have fun. That's your October surprise. Yeah.